All right, let's talk about set builder notation. I don't know why I have building. This should say builder. But here's the thing. I prefer interval notation. I'm just going to say it out loud. But set builder notation is a way for us to show a set of values that work for a particular situation. Okay, now the thing you have to really kind of keep in mind with set builder notation is that if we are dealing with a specialist group like integers or something, we need to be able to note that. Because if I just say it's between -2 and 2, that would be all the decimals, fractions, and everything between -2 and 2. So if you want it to only be integers, you have to note that. So let's just keep that in mind as we go. In our first example, we're going to talk about all real numbers less than 5. Now, recall that real numbers are literally, we've got decimals, fractions, positives, negatives, zero. All of these things are real numbers. So we kind of golden here. Now, when we're talking about all real numbers, so let's get our side piece here. We're talking about all real numbers. We'll represent them as x such that, okay, so that vertical line pretty much means such that. We're talking about all numbers x such that they are less than 5. Okay, so that first value there in x just represents, okay, x represents all the numbers we want, and then that second half kind of gives us the stipulation. We want them to be less than 5. All right, and because it's real numbers, there's not a whole lot to do with that x. But if we go to number 2, where we're talking about integers. Now, with integers, we don't want decimals, we don't want fractions, we simply want integers. All right, so when I go into here, I need to note that. Let's just say x is an element of the integers, right? So it's like a funky looking z with an extra line. And this is an e, it's an element. X is an element of the integers such that it is between -2 and 2. Notice I used the less than equal to sign because it's from -2 to 2. We want to include those endpoints of -2 to 2. So it's important that we have those equal signs there. But notice we had to note that we are only dealing with integers. So that's kind of an important piece here. Let's do another, all integers divisible by 3. Okay, so again, let's get our thing. And again, we need to say, hey, let's use a different variable. Let's use n. N is an element of the integers such that we have 3n. Because if you think about it, if n is an integer, let's just say 4, I plug that into on this side. 3 times 4 is 12. Is 12 divisible by 3? Yep. So we know no matter what we plug in for n, as long as n is an integer, then 3 times n will also be an integer, and it will be divisible by 3, which is the purpose of this. All right, so that's why it kind of works. And let's do one more. All real numbers between, but not including, -8 and 8. Now, here, again, we're back to all real numbers. So I can just say x such that. Because when we're talking about real numbers, we're talking about the gamut, right? Pretty much everything that we love. Well, as long as they're not imaginary. Now, I want them to be between, but not including, which simply means I will not have the equal sign with my inequalities because we are between -8 and 8, not including. And that equal sign implies that we are including the endpoints. In this case, we do not want to do that. So we just have x such that -8 is less than x less than 8. And that is just a couple of examples of playing with set builder notation.